In this video, I'm going to show you how we can simplify rational expressions. The importance of this topic is because before adding, subtracting, or multiplying, or dividing rational expressions, first we have to simplify rational expressions, then we add, subtract, multiply, and divide rational expressions. So this topic is very important. The first example is x to the 2 minus 3x over 4x minus 12. To simplify this rational expression, we can see that we have a common factor between these two terms in numerator. Between x to the 2 and 3x, x is the common factor. So we can factor x from these two terms. By factoring x, then we have x minus 3 in the bracket. Attention, if we multiply x again in the bracket, x times x is x to the 2, x times 3 is 3x. For the denominator, between 4x and negative 12, the common factor is 4. So we can factor 4 in the denominator. And then we have x minus 3. Attention, when we factor a common factor from an expression, basically we divide each term by that common factor. So to write this expression here, simply you can divide every single term by 4. 4x divided by 4 is x. 12 divided by 4 is 3. This is the way that you can write the expression in the bracket. Now look at the numerator and denominator. We can cancel the common factor between numerator and denominator. And the common factor is x minus 3. So we can cancel this with this, and then we have x over 4. So this is the simplified form of this rational expression. Now look at the next example. In numerator, we have x to the 2 minus 4. This expression should remind you a to the 2 minus b to the 2 identity, which is a minus b times a plus b. This is a very famous identity for factoring expressions. We can factor x to the 2 minus 4 with the aim of this identity. We can write x to the 2 minus 4 as x to the 2 minus 2 to the 2. And then we can factor it in the form of x minus 2 times x plus 2. So for factoring numerator, we use this identity. And then we have x minus 2 times x plus 2 in numerator. What about the denominator? In denominator, first we check for a common factor, but we don't have any common factor between 8, 6x and x to the 2. So we have to try to factor this as a trinomial. If you remember, the way for factoring trinomials is to look for two numbers. The way that we factor trinomials like this, when the leading coefficient, this coefficient here is 1, the way that we factor these type of expressions is that we put two brackets, and in each bracket we put x. Attention, x times x is x to the 2. That's the reason in each bracket we put 1x. Now, we look for two numbers. Please pay attention. We look for two numbers to put here and here. That the product of these numbers is 8. But we have many numbers that their product is 8. Like 1 times 8, 2 times 4, negative 2 times negative 4, negative 1 times negative 8. We are looking for two numbers that their product is 8 and their sum is negative 6. Between these pairs, negative 1 and negative 8, negative 2 and negative 4, 2 and 4, 1 and 8. Between these pairs, the only one that satisfies both conditions are these numbers. Negative 2 times negative 4 is 8. Negative 2 plus negative 4 is negative 6. So the numbers that satisfy these conditions are negative 2 and negative 4. So this is the factored form of this trinomial. If you want to learn more about factoring trinomials and other techniques for factoring, watch my video about factoring. I have a full video about factoring. So for denominator, we can factor the denominator in the form of x minus 2 times x minus 4. And attention, the order of writing these brackets doesn't matter. You can put x minus 4 first and then x minus 2. Because it's multiplication, and in multiplication, the order of the brackets doesn't matter. Now we cancel the common factor between numerator and denominator, and then the answer is x plus 2 over x minus 4. And we cannot simplify this rational expression anymore because we don't have any common factor between numerator and denominator. And this is the final answer for this question. Look at this question. 12 times 1 minus x to the 2 over 4 times x plus 6 times x minus 1. First of all, we note that 12 divided by 4 is 3. So we can simplify this number with this number. But what about these expressions? The denominator is already factored, so we don't need to do anything with the denominator. So we leave the denominator for itself. And I'm not going to simplify 12 by 4 right now. I will do the cancellation of common factors of the numerator and denominator after I factored numerator completely. If you want, right now you can simplify 12 by 4 and just write 3 here. But for now, I want to keep 12 in the numerator. How we can factor 1 minus x to the 2? 1 minus x to the 2, again with the aim of this identity, a2 minus b2 is a minus b times a plus b. This can be factored in the form of 1 minus x times 1 plus x. Now numerator is factored completely, the denominator is factored completely. Now we look for common factor between numerator and denominator. It is obvious that 12 with 4 simplifies, and then we have a 3 in numerator. So we have 3. We don't have anything to simplify with x plus 6 in the denominator. So we have x plus 6 in the denominator. And in numerator we have x plus 1, which we have to keep it in numerator. But what about these two brackets? Are they the same? Can we cancel 1 minus x from numerator with x minus 1 from denominator? Can we cancel this with this or not? This is the important thing that we have to figure out in this question. Please pay attention what we can do with these two. 1 minus x is not exactly the same as x minus 1. But you can cancel them with each other. So you can cancel this with this completely. But after cancellation, you have to put a negative in your answer. A negative 1 basically. Let me tell you the reason. When we have 1 minus x and x minus 1 in denominator, if you factor a negative from this, what happens? If you factor a negative from numerator, what happens? If you factor a negative from numerator, in numerator we have negative 1 plus x. And in denominator we have x minus 1. Attention, if you multiply negative by negative 1, it's 1. Negative times x is negative x. Now attention, this bracket is x plus negative 1 or x minus 1. And this is exactly x minus 1. So now we can cancel the bracket in numerator with x minus 1 from denominator, and the answer is negative 1. But if you want to make it more clear for yourself, please pay attention. We can write this as negative. Again, what we have in the bracket, please pay attention. What we have in this bracket, we have x, so x. And the other term that we have, and attention, between these two terms is a plus, so x plus negative 1. X plus negative 1 is basically x minus 1, which if we cancel this with this, the answer is negative 1. So let me summarize this story. We can cancel 1 minus x from numerator with x minus 1 from denominator, but when we cancel these two brackets, these are not exactly the same. They are negative of each other. So after cancellation of these two, we have to put a negative in our answer. A negative as a coefficient for our answer. We can put that negative, for example, here. Or you can put that negative here. It's up to you to put the negative in numerator or in front of your fraction. So we can write our answer in this form, for example. Negative 3 times x plus 1 all over x plus 6. Again, let me explain to you why these are the same, the negative of each other. For example, substitute a number for x, like 4. 1 minus 4 over 4 minus 1. What is this? 1 minus 4 is negative 3. 4 minus 1 is 3. When we cancel these two, a negative remains. And we put this negative here. So this is the important thing that we learned from this question. Whenever we have an expression like a minus b, and in the denominator we have negative of that, which is b minus a, we can cancel these two, but in the answer we have to put a negative, basically a negative 1. And this is the final answer for this question. Look at the next example. X to the 2 minus x minus 12 over x to the 2 plus 5x plus 6. In numerator we have trinomial, in denominator we have trinomial, and we have to factor these trinomials. And nothing is common factor between numerator and denominator, so we have to just factor numerator and denominator. For factoring numerator, we put two brackets, x in each bracket. Now we look for two numbers that their product is negative 12 and their sum is negative 1. And one of the numbers is positive, the other one is negative. Attention, because the product is negative, so it means that one of the numbers that we are looking for is positive, the other one is negative. And because the sum is negative, so it means that the bigger number is negative. Two numbers that their product is negative 12, their sum is negative 1, are negative 4 and 3. Because negative 4 times 3 is negative 12, and negative 4 plus 3 is negative 1. Now try to factor the denominator. We put x, and then we look for two numbers that their product is 6, their sum is 5. Those numbers are 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. Now look for common factor between numerator and denominator. You can see that this is the common factor. After cancelling these common factors, then we have x minus 4 over x plus 2. This is the simplified form of this rational expression. Now look at these examples. In numerator we have an expression with two variables, and also in the denominator we have an expression with two variables x and y. By looking at the numerator, we can see that both of the terms have x and y as a common variables, so we can factor something from numerator, some common factors. If we attention, also the coefficients have something as a common factor, 6 and negative 6. So from numerator we can factor 6. If we attention, here we have x to the 2, but here we have x. And always when we have a variable common between two terms, we factor that variable, but with the smallest degree. Between x to the 2 and x to the 1, the smallest degree is x to the 1. So we can only factor x to the 1. Here we have y to the 1, but here we have y to the 2. The common factor is only y to the 1. So we can factor 6xy from these two terms. By factoring 6xy, what happens in the bracket? What we have in the bracket? By factoring this from the first term, we have a negative x. Attention, negative x times this would be exactly this term. And then we have plus y. Negative x plus y. What about denominator? In the denominator, we have x2 minus y2. And x2 minus y2, by this identity, by this famous identity, is x minus y times x plus y. This is the factored form of the denominator. Now please pay attention. This is similar to this bracket, but are they exactly the same again or not? In the numerator we have negative x plus y, but in denominator we have x minus y. If you attention, this bracket is negative of this bracket. If you multiply the terms in this bracket in numerator by a negative, then you have this bracket in the denominator. So you can cancel this bracket with this bracket, but again, similar to the previous example, you have to put a negative in your answer because these are negative of each other. These brackets are not equal, they are negative of each other. So here you can cancel these two and then put a negative in your answer. So the final answer for this question is negative 6xy all over, so this goes with this, x plus y. Let me show you another method very similar to this method but a little different method for simplifying this rational expression. Maybe you like that method, which is very similar to this method, a little more. Let me show you the other way for simplifying this expression. Now here I want to factor not 6xy from numerator, I want to factor a negative 6xy from numerator. And the reason for that is that this term has a negative, so I think to factoring the negative also. By factoring negative 6xy from the terms in numerator, what we have to write in the bracket? Then we have x minus y. Because negative 6xy times x is exactly this, and negative 6xy times by negative y would be plus 6xy to the 2. And for the denominator again we have x minus y times x plus y. Now it's clear that this is the same as this term, and then after cancelling the common factor from numerator and denominator, this is the final answer, which is the same as the answer that we got from the previous method. Maybe some of you prefer this method compared to the previous method. Now look at the next example, x to the 2 minus 4y to the 2 over x to the 2 plus 2xy minus 8y to the 2. Again, for numerator we use this famous identity, a to the 2 minus b to the 2 is a minus b times a plus b. By using this identity for the numerator, we have x minus 2y times x plus 2y. The way that you can find these terms here is to take a square root from x to the 2. A square root of x to the 2 is x. A square root of 4y to the 2 is 2y. A square root of 4 is 2. A square root of y to the 2 is y. This is the way that you can find the answer. But for the denominator, x to the 2 plus 2xy minus 8y to the 2, how we can factor this? First we look for common factor. Is there any common term, common factor between x to 2xy and 8y to the 2? No, there is nothing common. So this is a trinomial, and the way that we try to factor this trinomial is like a normal trinomial. Here we have an extra variable y, and this is a little confusing. But if you follow the method that you know for factoring trinomials, you can follow that method for factoring this expression also. Let me show you how we can factor this trinomial. X to the 2 plus 2xy minus 8y to the 2. Again, as usual, we put two brackets. Because we have x to the 2, we put x and x here. X times x is x to the 2. Now, please pay attention. Don't focus on y. Suppose y as a 1. So, focus on the numbers, on the coefficients of x here and this constant here. So, please focus only on the constants that we have, because when you think to y, it's a little confusing. Just focus on 2 here and negative 8. Again, we are looking for two numbers that their product is negative 8 and their sum is 2. what are the two numbers that their product is negative 8 and their sum is 2? Those numbers are 4 and negative 2. So we have x plus 4, x minus 2. But we know that we have y here and y to the 2 here. So the factored form would be x plus 4y times x minus 2y. Now add y to your answer. So because we have y here, we ignore these y, actually we suppose them as 1. We focus on the numbers. We look for two numbers that their product is this, their sum is this. After we found that those numbers, we multiply those numbers by y. And this is the factored form of this expression. So as you can see, the way that we factor this is like a normal trinomial. The process is exactly the same. So this is the factored form of the denominator, x plus 4y times x minus 2y. Now this common factor cancels, and then we have x plus 2y over x plus 4y. Now look at this example. In numerator we have x to the 3 minus 3x to the 2 minus 18x. By looking at the numerator, we can notice that x is the common factor between the terms in numerator. So first we factor x from these terms. Then we have x to the 2 minus 3x minus 18. But for denominator, we have this expression 2x to the 2 plus 7x plus 3. The problem that makes factoring this expression, this trinomial, a little different than the normal trinomial is this coefficient here. If you check the questions that we have seen so far, always in the trinomial this coefficient was 1. And then we look for two numbers that their product is this, their sum is this. But when the coefficient, this leading coefficient is not 1, is a number other than 1, like 2, 5, 3, and so on, the process of factoring the trinomial is a little different. Let me remind you how we factor trinomials that the leading coefficient is not 1. For factoring trinomials like this, the process is this. First, you have to multiply this number, this leading coefficient, by the constant that you have here. So always multiply this leading coefficient, this number, by the constant. 2 times 3 in this case is 6. So we multiply 2 by 3 and it is 6. Now we look for two numbers that their product is 6, this number that we got from multiplying 2 by 3. And their sum is this 7. So find two numbers that their product is 6 and their sum is 7. Two numbers that their product is 6 can be 1 times 6, 2 times 3. But because the sum is 7, the numbers that we are looking for, are 1 and 6. Because 1 times 6 is 6, 1 plus 6 is 7. But the way that we want to use these numbers is not as before. If you remember before than this, we put two brackets x, x, and we put these numbers in here, and this is the factor form. But here the story is a little different. The way that we want to use these numbers 1 and 6 is that we write 2x to the 2, the first term. Now we split this term. We write 7x in the form of 1x, because if we got 1x or x plus 6x plus 3. X plus 6x is again 7x. So we write this middle term. The reason that we are finding these numbers is that we want to write this middle term in the form of these numbers, 1x plus 6x. But what is the reason behind that? Why we write 7x in the form of x plus 6x? The reason is that by doing this, now if we consider these two as a group and these two as a group, we have some common factor between these two. Between 2x to the 2 and x, the common factor is x. and we can factor x, then we have 2x plus 1. Between 6x and 3, the common factor is 3. Then we have again 2x plus 1. By factoring 3, from 6x we have 2x, from 3 we have 1. Now, as you can see, these brackets are the same. They should be the same. In this process, always we get brackets that are the same. Now we factor this 2x plus 1. We factor 2x plus 1. And by factoring this, from this term we have x, from the other term we have plus 3. And this is the factored form of this trinomial that we had here. So we have 2x plus 1 times x plus 3. So finally the denominator is factored. Look at the numerator. In the bracket we have a trinomial which is easy to be factored because it's a simple trinomial. We are looking for two numbers that the product is negative 18, their sum is negative 3. The numbers that we are looking for are 3. Negative 6 basically, and 3. Because negative 6 times 3 is negative 18, negative 6 plus 3 is negative 3. So this is the factored form of the numerator. And for denominator we have 2x plus 1 times x plus 3. As you can see, this is the common factor between numerator and denominator, and the simplified form of the rational expression is this. Now look at this example. 1 minus x to the 2 over x to the 3 minus 1. For numerator, we use this identity. A to the 2 minus b to the 2 is a minus b times a plus b. By using this, we have 1 minus x times 1 plus x. This is for numerator. And please pay attention. If you don't like to have this bracket, if you prefer to have x minus 1 instead of 1 minus x, first from these two terms you can factor a negative, then use the identity. But let's continue this way. What about the denominator? Here in the denominator we have x to the 3 minus 1. It's not x to the 2 minus 1. For factoring the denominator, you need to know this identity. A to the 3 minus b to the 3 is a minus b times a2 plus ab plus b to the 2. This identity is a little hard to memorize. And of course this example is a little challenging for simplifying. But let's try to factor the denominator. X to the 3 minus 1. For factoring x to the 3 minus 1, we want to use this identity. X to the 3 minus 1. But attention, 1 is basically 1 to the 3. 1 to the 3 is again 1. Based on this identity, this can be written as a minus b. What is a? A is x, b is 1. So x minus 1 times by a to the 2. So x to the 2 plus ab. A times b, x times 1, or 1 times x. 1 times x or x times 1 is x. And finally b to the 2, which is 1 to the 2, what 1 to the 2 is 1. And this is the factored form of the denominator. So we have x minus 1 times x to the 2 plus x plus 1. Now we can cancel x minus 1 with 1 minus x. And as I explained before, these two brackets are not exactly the same. They are negative of each other. So when you cancel these two, we have to put a negative 1 or negative in numerator or in denominator. So the final answer is negative. I prefer this time to put the negative in front of the expression. Negative, then expression. Negative 1 plus x over x to the 2 plus x plus 1. This is the final answer of this question. This is the simplified form of that rational expression. Maybe it seems that this is not really simplified, but at least here we have degree 3 polynomial, but here we have degree 2. This is a smaller degree, which means that it is simplified, although we have more terms. Here originally we had only 2 terms, but here we have 3 terms. But this is simplified version of the original rational expression. For this identity which I used here, let me explain something to you if you want to memorize it. If in the middle between a to the 3 and b to the 3 we have a negative, this is the identity. But if here is plus, sometimes we need this identity. If here is a plus, then here is also plus. So a to the 3 plus b to the 3 is a plus b. And then in the other bracket we have a to the 2 minus ab plus b to the 2. So if here is a plus, then here is also a plus, and here is a minus, not a plus. This is the identity that you can keep in your head for factoring expressions that involve power 3, like x to the 3 minus 1 or x to the 3 plus 1, things like that. I hope by watching this video you have learned how to simplify rational expressions, which is a very important topic for rational expressions, because for adding, multiplying, dividing and other things with rational expressions, we need to first simplify the rational expressions. So it's very fundamental to learn this skill. I hope this video was helpful for you.